Cool. Shall we start? Thank you. Um Thank you everyone. देरी के लिए क्षमा होता है. Uh, तो टुडे आज क्या देखेंगे? बेसिकली ये एंटेना जो है, ये एंटेना ये या ये चलता कैसा है? हाउ डज दिस एंटेना वर्क? ओके, और उसको बेस्ट यूज़ कैसे करना है? तो हम जो देखेंगे आज, व्हाट विल सी इज़ theory, of course, about 1 hour. उसके बाद we'll actually see it practically. तो यानी कि if you use this antenna, आपका स्कैन कैसे दिखेगा? If you use this, क्या दिखेगा? क्या प्रॉब्लम हो सकता है उसमें? What problems you can have in that? Okay? तो जब भी कोई क्वेश्चन भी होगा, जस्ट प्लीज़ आस्क. ऐसा कुछ फॉर्मेलिटी नहीं है. तो अभी व्हाट इज़ दिस रेडियो ट्रांसमिशन? Mobile phones, TV, radio, Wi-Fi, UHF is all the same. Okay, in principle, is the same. Okay, जो आप what you listen to car radio, 101 FM जो भी है, 93.4 FM. Okay, और 500 megahertz UHF, the same. What is sent on that radio wave is the same. No difference. Okay, so this is one, looks like a TV station basically. Okay, and all over the city you can see mobile tower hai, radio tower, TV tower जो भी है. So basically ये antenna से wave जो बाहर निकलता है या what comes into the antenna, वो what is that? Okay, तो there are two components. One is this, ये जो red line है, okay, और ये जो blue line है, ये दोनों 90 degrees out of phase. They are both 90 degrees out of phase. Okay, so any generator, RF, console, anything that gives RF out, LED walls, LED lights, anything, there are these two components, red component and the blue component. The red component is the electrical component, okay? And the blue component is the magnetic component. So we are not concerned with the blue, we are concerned with the red. Sorry, we are not concerned with the red, we are concerned with the blue, this E signal here, this one. Okay? So if you see this antenna, that means this, okay? The E signal is coming like this, the B signal, magnetic, is coming like this. Okay? We are concerned with this one, that's coming straight. Okay, now you have to remember this because बाकी के जो slides, what all will come, we'll keep referring back to this. So even in this one, so for example, if this is a Inear monitor, electrical is here, magnetic is like this. Okay, supposing you take, say, this transmitter. Okay, electrical is like this, magnetic is like this. We are concerned with this one, electrical. Okay, so in principle, it's the same, whether it's a radio station, TV station, mobile phone, whatever it is. Electrical signal is always in the direction of the antenna. So if the antenna is like this, electrical signal is like this. If the antenna is like this, electrical signal is like this. If the antenna is like this, electrical signal is like this. Magnetic signal is like this. Okay? Now, not too much technical, but wavelength, which we are all familiar. Subs, highs, tops, all wavelengths, okay? So, this one starting point, say leke, one full cycle, that is one wavelength, okay? Now, this is basically a calculation. So, basically, if you see subwoofers, they work on speed of sound. We are all working in the speed of light, okay? So much faster. And if you just remember these two numbers for now. So if you use a 500 megahertz signal, so that means this frequency is 500 megahertz, the wavelength is 2 feet. And over here, supposing you use 600 megahertz, the wavelength is 1.6 feet. So ये दो number जो है, just remember these two numbers because we will keep coming back to these two numbers when we talk about the design of these antennas, how are they designed. Okay, so remember these two numbers. So one full wavelength, that means from here to here to here is 2 feet. This distance is 2 feet. If your frequency is 500. Clear? Okay. Now, let's just consider we are using, our frequency is 500 megahertz, means the wavelength is 2 feet. Now, what happens if you have, say, this is my receiver, this is my transmitter. Between this, I have one metal wall that is bigger than 2 feet. Okay? Metal ka jo, metal, LED wall, whatever it is, the thing, the size of that metal, now I'm very nervous. The size of that metal wall is bigger than one wavelength, bigger than 2 feet. Okay, this is what will happen. So it will pass a little bit over the object, little bit under the object, but most of this jo either it will reach this, it will be reflected back. Okay, so think about शादी के shows, big LED wall. Okay, और कभी कभी बोलेंगे कि वो एंटेना डालने के लिए जगह नहीं है, LED वॉल के पीछे डालो या LED वॉल के ऊपर डालो. ओके, तो ये एक कंसिडरेशन है. अगर वो वॉल इज मेड फ्रॉम से कार्डबोर्ड या ग्लास या प्लास्टिक, तो फिर वो चल सकता है. वो प्रॉब्लम देगा थोड़ा, बट इट विल नॉट गिव यू अ बिग प्रॉब्लम. It will still pass. If it is made out of any metal components, means anything metal, PCB, mirror, okay, because mirror is glass, uske piche is metal. It's a metal, so it will reflect. Okay. Next one, if the object is smaller, then it will pass, no problem. Okay, so small things on the stage which are like, kya bolte hain, guitar amps, drums, whatever, they will not affect too much because the size of the object and there is space between them, you will be fine. Next is the space. This we see is also very normal. Big LED wall is there, one khacha will be given, uske piche console lagao, antenna bhi lagao. This is over here. Now if this space 2 feet se bada hai, no problem, iske through pass hoga. But if it is smaller than 2 feet, वो pass नहीं होगा. Okay, and we can demonstrate this very easily. So 2 feet is about so much. If the space is so much, think of a fence. Chain link का जो fence आता है. Okay, size is 3 inches, 4 inches का gap. The wave does not pass. Now there is one application like this, जो हम सबके घर में एक device है. What is that device? जो रेडियो वेव्स यूज करता है और उसको एनवायरनमेंट में आने नहीं देता है. एग्जैक्ट सेम प्रिंसिपल सबके घर में एक ये डिवाइस होगा. कैन यू थिंक व्हाट इज दिस? इट्स अ अप्लायंस, यू विल फाइंड इट इन योर किचन. हाँ, माइक्रोवेव. ओके, माइक्रोवेव डोर हैज those small holes. It's a mesh. Okay. So it is meant to not let the microwave waves, which is heating the food, to come outside. What will happen if the microwaves come outside? You will start, हम लोग पक जाएंगे. We'll start cooking. So this is exactly the same application here. और वो microwave का जो holes, they are very small because the microwave frequency is very high. Okay, so that's why that hole is maybe 1 mm, 2 mm, बहुत छोटा है. It's to not let the microwaves, what's happening in the microwave, actually come outside. If that was there, it would pass through that glass door and come outside. So we can see inside what is happening with the food. Okay, but what is happening to the food, that heating does not affect us. Cool? So think about other applications of this space. Antennas may be behind a truss, blocked slightly by a truss. Okay, again, same principle. The truss bars are smaller than 2 feet. Okay, think about this. So if your antenna is by some chance behind a truss leg, then this is the principle that is kind of happening. Okay, now frequency bands. So everything in here, VHF, that means a radio. So um, your radio stations, 94, 95, 100, 200, whatever it is, not 200, 100. That is all here. Walkie-talkies, everything is here. Old VHF systems, microphones, which is still actually used by, in your tier 3, tier 4, mandir. They use those small ahuja radio stations. Those are all VHF. Okay. Then this is where we are currently, UHF. At the moment, we are up to here, 700. Okay, but I don't know if you've been checking the news, but 700 and above has been sold to 5G. It's not sold directly to 5G yet. It's just now, it's still with the government. They are selling it to disaster management. So ambulance, earthquake, landslides, when there's a disaster, those frequencies will be used by government, which means at a certain point, you'll not be able to use above this. Yeah. Okay? The 5G is actually here, which is very expensive. If you were following the Spectrum auction last year, early this year, it's too expensive. So no one will buy it just now, but at some point, mostly our friends in Mumbai will, Ambanis will buy it. Jio will end up buying this. Okay? Then this is Khali. This is all your currently what is 4G is here. 4G, 3G is all here. This is DECT, which is cordless phones. Old time cordless phones that you have in the house is all this. And then this is 2.4, 5.8 Wi-Fi. Okay. So now you can see the frequency increases from 100 megahertz up to 5 gigahertz. Okay. Most important thing to realize from here is as the frequency increases, the range reduces. Okay, so what is Wi-Fi range? Wi-Fi means you go into that room, then you don't have Wi-Fi. Cordless, you go into some other room, there's no Wi-Fi. Where are we here? Mobile phones. So unless a tower is very close to you, mobile phone reception, you're not getting. Okay, here 100 meters, 120 meters is clear, line of sight, no problem. And here more, 1-2 kilometers. Your radio station, 2-3 towers will give to the entire city. Okay, so that is all here. Okay. Okay, so first we're going to talk about analog RF transmission. Now, everyone's making digital RF. Okay, but it is not digital RF. It is still analog RF. Difference is what is actually going from my mic into this body pack to the receiver. What is going is a digital signal. The theory is still RF, it's still analog. It's an analog system. Okay, what is going, like how you, supposing, आप लोग show record करते हैं, okay? Your Pro Tools, Logic जो भी है, उसमें record क्या होता है? It's a digital signal that gets recorded there. That digital signal is what is going from here out. In the radio, you're sending an analog signal. Okay. Now, first difference. When you listen to any music, maybe CD, original CD, whatever it is, and when you listen to the radio in the car, वो फर्क है. It does not sound great. It actually sounds average. Okay. और जैसे रेडियो का RF signal कम ज़्यादा होता है, the quality of the audio changes. Correct? So supposing you don't get radio signal, okay, you start hearing and the radio does not sound good. But when because of the RF also it changes from stereo to mono. Okay. Now in digital systems we don't have this problem. So digital systems I can get 1 point of RF, it will still sound the same. Okay, that is the fundamental difference between analog and digital. There are some other differences which we'll see on the spectrum analyzer later. Okay, but the main difference is that in analog systems, the quality of the audio depends on the quality of the RF. Okay, bad quality of RF, bad quality of audio. In digital systems, even if you have bad quality of RF, the audio sounds the same. Okay? In digital, it will work chalega, 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 जब तक RF है नहीं और फिर cut off. ऐसा नहीं कि as the RF goes down, the quality of the audio will change. It will not change. It will be the same. Okay, so 3 signals. 500 megahertz, if we have tuned to this is the carrier signal. Okay? 500 megahertz, we've tuned the 600 jo bhi hai. This is the carrier. Base band yani what voice we are sending. So this, what I'm speaking, is the base band signal. और इन दोनों को मिला के you get the final output signal जो यहाँ से जा रहा है and will come to this antenna. Okay? So carrier signal, baseband signal, voice, and you mix these two, modulated signal is what goes out to the receiver. Okay? In very simple terms, we don't need to worry about the math and all that behind it. So a typical car system, your modulated, your carrier frequency is 87.9. Okay? Music is coming is your baseband signal. Okay? And this is picking up FM. So same concept in pretty much everything else. Now you'll see, why are computer sound cards? These are not wireless. Why are synthesizers here? These are not wireless. But these devices also emit RF. And they emit wideband RF. Like how you have white noise. When you tune your PA, pink noise, white noise. Same, but in the RF spectrum. So you can get right up to lower VHF, up to higher in the 2.4 range, wideband noise. If you are sometimes close to consoles, and your antennas are pointing to consoles, pointing to LED walls, pointing to lights, it's wideband RF that all these devices emit. Okay, तो ये हम लोग कल मैंने 2-3 scan किया है, basically with this antenna, then I've done with this antenna, and then combination, one this. Okay, and you'll see as the combination changes, that full RF noise floor starts to come up. So what we will discuss is what is the best types of antenna to use based on your application. Okay, so ये standard FM waveform. This is what we are all using. So see, change in amplitude. This is your final signal here. Notice, every time there is a change, take it one back. Okay, every time there's a change in this frequency. This is how FM works, basically. This is change in amplitude. Now you'll see change in frequency. Okay, change in frequency means there's a quick change to tell the modulated signal something has changed. Okay? Now, look at this picture. Okay, so when, let's take, say, old SLX system, SLX, BLX, Sennheiser, EW, analog systems, okay? That waveform, जब आप इसको on करेंगे, will look like this. और जब आप उसमें signal भेजेंगे, when you talk into the microphone, it will look like this. Why? Okay, now here's the reason. This is F0 means अपना carrier frequency, 500 megahertz. F0 minus, you see this deviation जो लिखा है, F0 plus. ये deviation क्या है? Any idea? Why when we are talking, does this become bigger? When we are not talking, it stays like this. Yes. What is अपना audio signal का bandwidth क्या है? When we speak, और जो हम लोग कान से सुनते हैं, उसका bandwidth, what is the bandwidth? 20 to 20 kilohertz. Huh? So that is this over here. Yes. Yes. But for analog transmitters, This is from 50. In a good analog system, it will be up to 15 kilohertz, 1.5. It's not 20 to 20. In pretty cheap systems, this can be around 80 to around 12K. So if you use a very cheap analog system to put on, say, bass guitar, that's when you'll realize that there's not getting enough low end, because those signals only take 60 and above, 50 and above. If you put it on a dhol, for example, the baya, again, because this is 60 and above. And these are all analog systems. Okay. In digital, when you turn this on, it looks like this. Also, when you speak, it also looks like this. Okay? That is the digital system. You don't have this space. And that's why if you see any manual, say take this SLXD. Okay, old SLX, 12 channels per frequency band could do. BLX is 9. Okay, SLXD, 31. Yeah, and that is this reason here, that it does not take that deviation space, second picture. It does not take that space. Yes. And so what is transmitted on this is basically a digital signal, 0101010101, जैसे हम लोग computer में record करते हैं. Okay, exactly like that. And to see it, say for example, I can show you, just to get an idea. Okay, so let's open, say, one of these waveforms. Okay, and let's zoom in as much as possible. You see these? These all 0, 1s, 0, 1. So, these points. These points is what is transmitted on this digital signal. In analog, the full waveform is transmitted. Okay? And all these transmitters are sending, some of the lower price ones send 48 kilohertz 24-bit, and the higher ones can send 96 24-bit. Okay, so Axion Digital is all 96 24-bit. Yeah. Digital transmitters actually don't require a lot of things. So, Squelch is the first thing. Okay, Squelch is not required, and mostly in any of the Shure digital systems, that Squelch algorithm is different. You never have to do Squelch on a Shure. What is Squelch? Okay, so Squelch is basically, now consider how well your receiver will pick up this signal when compared to some amount of noise floor. It's a gate, basically. Squelch is a gate. Okay. Now, you would remember the older Sennheiser systems. If you didn't set the Squelch correctly and you turned the mic off, okay. So now, none of the Shure systems have a Squelch. That is, the system in which we work is completely different. It is Squelch. It's done internally by the device. Yeah. Okay. So that is, so supposing my noise floor is here, and my gate is set, or my Squelch is set here. What happens if the transmitter goes off? You get that noise. If my noise floor is here, okay, and my gate is set here, and the transmitter goes off, what happens? It is clean. It turns off. Just so Squelch is a noise gate, like just say what you put on kick drum, snare drum, toms, whatever. It's the same. Principle is the same. It's a gate. It's a noise gate. Okay? So there's no Squelch. There's another thing in analog systems which is companding. Okay? So how do you send? Why does the signal on an analog system, when you listen in the car, why does it not sound correct? वो same song का अगर आप CD डालोगे, it will sound much different, much better. But when you listen on the radio, there's a lot of analog processing which happens before it is transmitted. Okay, companding is one of them. So companding is simply, anyone's aware what companding is, or it will become too technical? Yeah. Okay, क्योंकि वो, when you have to send bandwidth on analog, the dynamic range, what you call, सबसे soft noise से लेके सबसे loud noise, वो बहुत कम है. तो ओनली वे टू सेंड इट इज पूरा आपका जो सिग्नल है म्यूजिक उसको पूरा कंप्रेस करो, फिर भेज दो, दूसरा साइड पे उसको एक्सपैंड कर दो. दैट इज कंपाउंडिंग. अगेन एनालॉग सिस्टम्स नॉट रिक्वायर्ड इन द digital systems. Similar to how it goes in a tape recorder. Yeah. Okay. Another thing with regards to, and this is specifically with regards to the Shure kit, is that there is no now gain setting for the microphone coming in, क्योंकि ये होता है automatically. Okay, तो previously you used to take a screwdriver, whatever it is, set the gain, कि वो transmitter distort ना हो, वो अभी करने का ज़रूरत नहीं. And that is same from SLXD to Axion Digital. It's all the same. जो आप connect करते हैं उसमें, हाँ, वो decide, transmitter intelligently decide करता है gain क्या होना चाहिए. और वो आप कुछ भी try कर सकते हैं, वो transmitter distort नहीं होगा. It will not distort at all. Not required. Not required. Yeah. Not required at all. And starting point for any Shure system is now in the digital side is 0 dB on the transmitter plus 12 on the receiver. That is line level coming out from your device. अगर आपको line level नहीं चाहिए, mic level चाहिए, bring it down to -2. Okay? Okay. So first thing we saw was now why ये सब receiver में दो antenna होते हैं? Why there two antennas? Why not one? Diversity. Correct? Diversity क्या है? Redundancy. कंसोल में क्यों दो Cat 5 घुमाते हैं? क्यों दो BNC घुमाते हैं? क्यों नहीं एक? क्योंकि वो कटेगा तो फिर का प्रॉब्लम है. तो बेसिकली ये क्या होता है कि सोचो मैं अभी ये ट्रांसमिट कर रहा है, दिस विल कम, ये थोड़ा डायरेक्ट आएगा इसको और ये थोड़ा इधर जाके रिफ्लेक्ट भी होगा. ये एंटेना का क्या जॉब है या रिसीवर का क्या जॉब है? जो डायरेक्ट आएगा सिग्नल उसको पिकअप करना है, जो रिफ्लेक्ट होता है उसको नहीं पिकअप, उसको रिजेक्ट करना है. ओके, तो देर आर टू एंटेनास बिकॉज ये रिसीवर देखेगा कौन से विच वन एंटेना इज गेटिंग द बेटर डायरेक्ट सिग्नल, उसको डीमॉड्यूलेट करके ऑडियो में निकालना है. ओके, सो इफ यू सी दिस पिक्चर, सो दिस इज ट्रांसमिटिंग हियर डायरेक्ट, इट इज ऑल्सो ट्रांसमिटिंग फ्रॉम द वॉल. ये इंटरनली कंपेयर करेगा विच इज दिस ग्रीन सिग्नल. सो ग्रीन सिग्नल इज कमिंग मोर टू दिस से एंटेना 1, तो दिस वन विल डीमॉड्यूलेट ऑडियो, इधर से बाहर आएगा, इट विल नॉट यूज this antenna. Okay, so this system is in SLXD, QLXD, ULXD. Axion Digital, the system is different. Okay, Axion Digital में क्या होता है? It will remove this also. इसको भी demodulate करेगा, इसको भी demodulate करेगा. And then because it is 1 and 0, 1 0 1 0 1 0 1 0, इसके अंदर there is one जो बोलते हैं like a error checker. So जो सिग्नल में एरर है उसको नहीं लेगा, जो है सिग्नल में एरर नहीं है इट विल टेक द अदर वन. ओके, सो सी दिस एनिमेशन. So whichever side is closest, whichever side is getting more direct signal, that antenna it will demodulate. About 3 feet. One wavelength, so 2 feet, 2 feet to 3 feet is the distance that you require. Now, to give इसका एग्जाम्पल अगर देखोगे, सोचो एक वेन्यू है, हाँ ग्राउंड है, अगर आप सोचो एक स्पीकर यहाँ पे डालोगे, ओके, दूसरा स्पीकर यहाँ पे होगा, ये दिस इज द नॉर्मल सेटअप. ओके, अभी सोचो यही सेम वेन्यू है, आप ये स्पीकर को पीछे लोगे, क्या होगा? फेज डिफरेंस. तो आपको टाइम अलाइन करना पड़ेगा, यू हैव टू टाइम अलाइन दिस स्पीकर, वेट टिल दिस वन कम्स. ये आप एनालॉग में, ये आप आरएफ में नहीं कर सकते हो. So it is always a bad practice जब आप diversity use कर रहे हो to have the antennas one behind another. They should as far as possible be in the same line. Hmm? And about 2 feet distance. Okay? These? Or the ones at the back? So yeah, because if you see, this is 19 inches, the rack. 19 inches is 1.5 feet. So even if you put the antennas here and here, ये भी हो गया about 1.5 feet, which is still enough. And then you splay them, and there is a reason for actually splaying them, which we'll see. Yeah, so the whole lot of these designs are made with keeping a lot of these ideas in mind from a very long time. Okay, so because we are using 600, 500, which means 1.5, 2 feet is the wavelength. Okay, approximately, if you see this, this is a 19-inch rack. 19-inch means sitting right in the middle. Hmm. 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 It is only useful if you really have to do that. The problem is that if you put जो दूसरे side पे, supposing rack is here, okay, एक एंटेना केबल छोटा है, दूसरा एंटेना केबल बहुत लंबा है, तो आपने उस पे कैलकुलेट किया है कितना लॉस होगा वो केबल पे, उसको मेकअप किया है कुछ, अगर या अगर नहीं करेंगे तो फिर प्रॉब्लम है. एक्टिव एंटेनास, अगर आप पैसिव एंटेना ले रहे हो, एक ये साइड पे एक वो साइड पे, वो मुश्किल है. अगर तुम्हारा एंटेना केबल जो है, नो यू हैव टू डिसाइड, वो आपको कैलकुलेट करना है, वो आपको कैलकुलेट करना है. ओके और वो ज़्यादा डिफिकल्ट नहीं है, वो काफ़ी सिंपल है एक्चुअली. यस, तो यू कैन पुट हियर एंड देयर, बट देन यू डोंट गेट द multipath interference, basically diversity you're not getting now. So it is either getting one on this side or it is taking one on that side, which is, it's not required. Because even on a stage, bada bhi stage hoga, 100 feet, 200 feet, the range of all these devices is up to 100 meters in line of sight. It's not required at all. It's not required. Yeah. Yeah. Hi. Antennas. Yeah. We'll come to that. We'll come to all of that. How to put it. Yeah. Hmm. Yeah. Hmm. Yeah, because your dress is made out of metal. What happens if you wear a metal dress with a antenna inside it? You tell me. What should be done? No, so that is not the correct way. The thing is that there is a solution for it. Of course there is. It's a little expensive solution also. That you have to expose the antenna. So if, huh, correct. Did you scan for frequencies? Then maybe the system was faulty. I don't know. Unless you recreate it, it should not be a problem at all. Hmm. Hmm. So there could be, see, there could be a lot of reasons for why that is not. There could be either, I don't know, maybe from where she's speaking, they could be getting a lot of loss maybe on the cable, maybe when you're speaking closer. It could be a lot of things as to why it would not work. Another thing is if you're using these and it's on the body and it's touching the body, there is actually I would say a 60 dB loss because the antenna touches the body. So there are ways to work around that. When you checked it, did you check it in your hand, or did you check it in the same place? Hmm. 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 Huh. Yeah. Huh. 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 Yeah. So it might possibly be that firstly your RF gain structure was extremely bad, and then because you had the antenna over here, the body pack and this thing touching, you're losing about 60% of your power just because the antenna is touching a body. Now, there is a way to make that work. Hmm. Hmm. So, I mean, see, there could be a lot of things. There could be a lot of issues. Hmm? Hmm. Could be a lot of things. There's no real one answer as to why. Yeah. Yeah, person to person is also different. There could be a lot of issues. Hmm. 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 Yeah. Yeah. It's definitely possible. See, you have to understand one thing. There is um, this whole RF thing, you cannot see it, you cannot hear it, you cannot smell it, you cannot taste it. So you have to know what is happening in basically when this is like this versus this versus this. Until, and you have to know the calculations of these cables. Until that is done, you know, uh, right, right, right. But what system were you using? QLX D? No idea. Can be anything. Can be a lot of factors. Like the only thing we can say is at least we are using these systems, say for example, on like a AR show, for example, up to 60 channels. Antennas are proper 100 feet away sometimes, with no issue whatsoever. And they are wearing dresses and gowns, and the antennas here, or sometimes here, sometimes it's on the foot over here, with no real. So there could be a lot of issues now. Until the problem is when you're on a show, it's difficult to troubleshoot sometimes. How much time do you have to troubleshoot? So you try something else. If it works, great. And then maybe send the QLXD for servicing. Maybe you just need it to be serviced. Maybe there was something wrong with it. Could be a lot of issues. Yeah? Cool. Okay. Last thing is this, which is inverse square law, means you double the distance, you get 4 times less power. Okay, so someone at a show will come and say, boss, ye antenna idhar se hatao, udhar dal do. That means there is some implication in that. So it could have, think it's a very big stage, 150-foot stage. And now you have increased the distance maybe by 20 feet. Okay, that 20 feet could mean a lot of issues. If things like this calculation of this RF cable, the antenna power, etc., has not been taken care of. Okay, that is this slide over here. Okay, and last is, this is what I was talking about at the beginning. This is your RF noise floor. So think if you're doing some ballroom show, drums, loud guitar, bass, jo bhi hai stage pe, how much is it possible to make the singer much louder, considering stage is very loud? Stage is naturally very loud. Think some big Punjabi artist. 15 monitors are there on stage. Loud drums. Everything is loud, 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 loud. Is it easy to make the vocal stand out after that? It's a little difficult. The same principle over here. Okay. So as long as your noise floor is reasonably low, and this noise floor is then everything from console emission, LED wall emission, LED lights emission, can be a lot of things. Okay, so this is the maybe as per manual operating. This does not happen most of the time. Most of the time we are here in this area here, where noise floor also is little high. This is a bad situation over here. It's not far. It's not even that. Usually it is just which antenna to use in that situation. Which is these should be avoided. This, don't point it towards the LED. You can actually, one good thing practice is actually if, say, okay, let's see, this is the monitor console here. Your LED wall is here, okay. Rather than have this front of stage pointing in, you have this at the back and pointing out. Because the pickup for this antenna is here. And there is some amount of rejection over here. Okay? And all these things we can try today. So what we can do is, I've done some scans yesterday which I can show you, but what you can do is take this antenna, for example, as long as the cable goes, point it directly at the console and do one scan. And you'll suddenly see a nice jump in RF noise floor. We don't have an LED wall here, but maybe you could take it, point it at the TV, do another scan. You'll see a small increase. Now consider if the screen is 60 feet, 70 feet, a big stage, big screen. Doesn't matter. Hmm. 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 Yeah, if they're all microphones, you should not ideally have an issue. If it's microphones slash in-ear monitors, we'll definitely have a problem. We'll come. Yeah, we'll come to that with a nice. We'll need one volunteer for that part when it comes. That's a correct question because, and say even in this rack, for example, I have an in-ear monitor here. I have microphones here. But if I do my antennas properly, I will not have a problem to run it like this. Coffee or anything, there's coffee also outside. Otherwise, if we have a few more slides, we'll take a small 5-minute break, can have some coffee, and then we can continue. So as long as my antennas are done properly, so currently this SLXD, Axion Digital, is running into the distributor. And this is separate. मैं इसका antenna ले सकता हूँ. I can put separate antennas. So there's no problem to have the equipment in the rack, in the same rack. The problem is the antennas being too close to each other, and there is a way to work on that. Huh. Yeah. So actually, while we are on that topic then, before taking a break, let's actually see that. Okay. So let's take one volunteer. Who wants to volunteer? Volunteer to come. Okay. Now, okay, my in-ear monitor, this PSM for example, can go up to 100 milliwatts. Okay, this can output up to 100 milliwatts for the in-ear monitor system. This transmitter, digital transmitter, is running at 10 milliwatts digital power. Okay, by the time it reaches this antenna, कितना बाकी है? Almost zero. Because वो सब air में loss होगा, इधर loss होगा, cable में loss होगा, जो भी है, तो इधर तो बहुत कमी आएगा. Okay, अभी ये देखो. Supposing मैंने अभी ये antenna अभी के लिए सोचो ये SLXD में डाल दिया. Okay, let's just place it. Okay, this is my PSM 1000 antenna. ये कितना दे रहा है? 100 milliwatt output. और ये ट्रांसमीटर से कितना रिसीव हो रहा है? Very very small, बहुत छोटा. Okay. Now think of this. Supposing this in-ear monitor, like this same setup, this in-ear monitor antenna is behind the transmitter antenna, or also to the side by side. Huh? So ये close your keep your eyes open. Okay. Okay, that is what happens, which is you're basically firing so much power from this into this antenna. You are overloading this antenna, whatever antenna is here. You, yes. One is receiving, and one is transmitting very high power. One is receiving very in microwatts. It's receiving. So it is like if you turn on some car headlights and then stand and look at the car headlights from so much distance. Can you see anything else around you? No. That is the problem. So this is basically the headlight. Okay? So this headlight is here, and now this antenna is trying to see something very small from very far. But this is the headlight. It is shining straight into the eyes. You're not going to be able to see anything. So your in-ear monitors might work still because the RF power is very high, but your mics will not work. Your mics will give you trouble. So the solution for that is to separate them. Or you move the receiving antenna in the front. Receiving antenna has to go front, transmitting, sorry, I mean the transmitting antenna has to go in the front, the receiving antenna has to be at the back, so that the transmitter is not overloading this antenna. So this PSM or whatever, in-ear monitor antenna has to be here, aage. Okay? If it's like this, yeah, as much as you can get, if possible. But ideally, for any distances, if you're calculating, 1 or 2 times the wavelength. So that means 2 feet, 3 feet, 4 feet is good, is ideal. Okay, now it depends on the antennas also. So you'll see, I have one picture with, again, it's a AR Rahman show. There's a full antenna array. There are 7 antennas, but they're all helical antennas. When you use helicals, now that's a much better way to work if you have multiple antennas, because they don't affect each other this way. Yeah. Doesn't make a difference. It's not a problem. It's how the antennas are placed which causes the issue. So the thing is that sometimes a system that might cost you 15, 20, 30, 40 lakhs will fail because the antenna position is not correct, or the antenna cable is not good, or you've not calculated the gain, and you have basically then not set these amplifiers here if required. So it's not the equipment, I would say, most of the time, unless the equipment is faulty. It might be the smallest thing of the antenna position. And it is not, see, Vikrant, it's not like, you know, how sometimes some engineer will come, they'll change the position of the mic, you know, kick drum mic, they'll change snare drum. It's the same. It's not different. It's just that the systems are very robust. They will work. But in that 1% chance, when there's a kind of a situation is difficult, that's when you'll have the problem if you're not aware of how these are working. Yeah? Yeah. 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 Move them away like this, or like this, up and down. But, yes. Yes. And we can actually try that. So we'll put, maybe we'll get a cable out from this PSM. Right now it is 100. We'll run it at, you know, it's 10. We'll run it at 50 milliwatts. And keep this antenna right in front. And you'll immediately see that this overload light will start blinking. Okay? This overload light is like you putting some SM58 in your console and distorting it from the preamp. It's not a good thing. Okay? The systems, they are developed to manage it to an extent, but not, once you distort your mic, you cannot save it other than reducing the gain. Same principle. Okay? So if you guys want to take, okay, let's finish. Oh, we finished one last slide. Even worse, bigger problem. Yeah. And that I'll actually show you from the scans. There's about a 6 dB increase in the noise floor. You'll be surprised once you see the scan. When you're using this, it's rejected a lot of noise from I don't know where around. Yeah. The moment I've switched to this, suddenly, you'll see when I show you the scan, then you'll see the difference. Yeah. But they're not really using much IFB there generally. If they're outdoors. Yeah, I mean, there's not much IFB happening there. So outdoors, it's a one-way communication. It's mostly to the producer, who's possibly on a mobile phone, telling the anchor what to talk about or speak. So there, it's not such a big issue. Overall, you have to be very careful of the choice of antennas. And I'm not saying one antenna will work for everything. It's difficult to make one antenna to work for everything. It is like how one mic will not work for everything. Sometimes you have to change mics. Sometimes on a show you might use only kick-in mic. Sometimes you might use only out. Sometimes you may use both. But you have the options. It is the same when it comes to selection of the antennas based on once you've done, and most importantly, once you've done at least one scan at the venue when you have started working. So there are a lot of times when we'll choose antennas, maybe we'll start the show with this, we'll finish with this. Because Some part of the show requires a different antenna. It's very simple. We will start a corporate show with this, and when the band is on, we'll finish with this. We'll replace the antenna. Okay, it's all about noise floor, carrier to noise ratio. Okay, so various forms of interference. Which do you think from all these pictures is the biggest source of interference from all these? Which one? Actually, the biggest is consoles. Yeah. The biggest is lighting, sound consoles are the biggest source of interference. Then after that, I would say LED walls. Then after that, your computers, other RF equipment in some neighboring venue, maybe over here. And then last but not least, it's your TV stations and radio stations. Okay, now there is a reason why sometimes, and we hear this lots, when you do a show next to an airport, close to a TV tower, close to a radio station, we are not working in that range. We are working in 500. So when that is 100 megahertz, why is it bothering us? Okay, and there is a reason for that. The reason is similar to your PSM example, your in-ear monitor example. You are sending so much power from that. These are running, say, 50 milliwatts. Any idea what a radio station transmitter works on? Yeah, 50 kilowatt, 100 kilowatts. Especially if it's a smaller city where they can use one transmitter, that power will be more. In a bigger city, the transmitter power might be less. So 50 milliwatt to 1,000 times more, 50 kilowatts is what they're running. Yeah. 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 See, guitar amps are different because then that guitar cable starts to behave like an antenna. Okay. Yeah, yeah. That's a tough one. And usually it generally will end up being something in the electronics of the guitar that's letting that signal through. There's usually a blocking capacitor next to the volume knob. If that is faulty, the guitar will sound still average, but this blocking of noise does not happen. As soon as he starts playing. Exactly. Yeah. तो वो जब होता है ना, when that happens, वो guitar से that noise comes, there's one capacitor that is in the PCB of that guitar. Very often, if that capacitor is spoilt or is not connected properly in the circuit, that is when you hear this guitar से noise जो आता है. वो हम लोग fix नहीं कर सकते. That is the guitar player's problem. पर वो है, that is the issue. That is that is why it happens. Okay. So see this tower over here. इस पे antenna कहाँ है? Where is the antenna over here? This is an old radio station. Yeah. This entire tower is actually the antenna. Okay. These are old AM stations, which is or shortwave. So shortwave used to be 1 megahertz, 2 megahertz, 3 megahertz. No one I think uses shortwave anymore, but this is a shortwave antenna. This is all your mobile GSM type antennas. Okay. Now this antenna here is a directional similar to something like this. This antenna, round one, is a helical antenna. Okay, similar to the helical antennas that we use on stage. So there's actually a coil inside this. This is a helical antenna. Cool? So we'll take a